Hello, everybody. I'm Nicolas Stanitas, Senior Advisor at the Luxembourg Digital Innovation Hub. Welcome to this new webinar of this L-DIH Talk webinar series of 2022. So first of all, a few tips and tricks regarding the platform, how we could use it, and the different tools you would find on it. First, be advised that this webinar is recorded and that the replay will be available on the Lux Innovations YouTube channel. Then, about the chat, so there's a basic chat, something that what we could interact during the session. Important, the questions section that you will find also at the right. During the presentation of our speakers, I invite you to ask your question here, because if we ask them on the chat section, perhaps we will miss it. So use this question tab specifically for questions. Then the polls, there are 3 polls that will be done during the session in order to get to know each other. So there is a dedicated tab also for that. And there's also people section in which you will see all the people that are attending this webinar. So this episode 6 is dedicated to IoT. In a nutshell, IoT solutions consist of web-enabled devices such as sensor and communication hardware that are able to connect and send data they acquire from their environment towards systems capable to analyze this data, build some information out of that, and finally take action. But first of all, for those who don't know us yet, who are we, the Luxembourg Digital Innovation Hub? Basically, we are a one-stop shop for the digitization of the manufacturing companies of the country. We're aiming at connecting requirements and solutions provided by the 8 and more actors that are listed on the right of your screen. And as we become a European DIH in the coming months, we'll extend our activities, particularly in the greater region, by establishing some cross-border collaboration between manufacturers and enablers. The enablers for us are all the companies, all the organizations, public as private, that could help the manufacturing industry in its digital transformation. So in a nutshell, all the activities we conduct throughout the year, they aim at informing, inspiring, and engaging this whole community. All the activities, as mentioned, they count a survey, and all the webinar we are conducting this year is mostly deriving by the insights we collected through this survey that you could find at the address mentioned, and that is currently shared to you. So this survey has the ambition to better know where does the industry stand at the moment in its digital transformation and what's its plan for the future. And as IoT seems to be establishing itself as one of the important underpinnings of the digital transformation of the industries, we've included in the 9 proposals to this question, so this question is part of this survey, we've included IoT in it. And there's 9 propositions that have been done, and all are related to the facilitation they could provide to the manufacturing sector. So what's the result for this question? So 1 out of 4 respondents have answered that, yeah, they are currently trying or thinking to use IoT. So there is a trend, but still a little timid. So let's see in this webinar, let's see as an opportunity to go deeper in the topic, discover the solutions, but also the players in the field, and discuss also the opportunities and risks of this technology. But first of all, before jumping into the first presentation, let's get to know each other through this first poll. So on your side, do you collect by any means, no judgment about that, some data related to your production? So yes, and I make an extensive use of it, yes, but I do not use or take any value out of it. Perhaps no, because you didn't find the time, the support, the financing for such project, or perhaps you don't see the need at the moment that could be covered by the IoT, so you're not into this technology yet. So we'll discuss the result later. Then let's introduce our host. So when we talk about IoT in industry, we can go through 2 axes. First, seeing IoT as an enabler for the digital transformation of the manufacturing sector, but also IoT could bring some new functionalities to the equipment you produce as an OEM, for example, and thus adding some value to it. Today, we have the chance to have speakers that could talk about these 2 sides of the main coin. And I would like to introduce you our first speaker, Luc Verschaffel, Managing Partner of 5A. Welcome, Luc.
Thank you, Nicolas. Thank you for the introduction. So I will share directly my presentation. So hello, everyone. I hope you hear me very well. So I'm very happy to participate to this Digital Innovation Hub Talks, number 6. So basically, let's go. I don't know how to get us. Yeah. Okay. So sorry for the introduction, a bit blurry, but 5GA, which I represent, is built from 2 companies. 5A Box, which is a company that I found back in 2014 in Belgium, and we develop software dedicated for the IoT. And GigaConcept is a French company, which is specialized in radio communication, hardware distribution, and propose integration and training services. So we both companies are pioneering in the IoT since about 10 to 15 years. And we made a new company in Luxembourg because we find that Luxembourg is a quite digital friendly environment, and there is a lot of things to support new projects and innovation. So what are in a nutshell, the key success factors for IoT? And I will mix IoT and IIoT in this presentation because basically the fundamentals are about the same for both appellations. So IoT projects are very complex, and that's the reason why the IoT projects are still not mainstream. We would just see the polls sharing that 25% of the company start to deploy IoT, and the main reason is complexity. Why complexity? Most IoT projects are made of business purposes, and the main business purposes of IoT projects most of the time are processes, productivity improvement, or cost cutting, controlling, monitoring, for instance, energy management, but as well physical security, risk prevention, and emerging. We have a regulatory framework which is emerging in Europe and in most of the country. So we need to deal with regulatory and legal constraints. But at the same time, the business purposes are quite complex, but the technology which is involved to solve those complexities are complex as well. An IoT project is a networking project, it's an IT project, it's a cyber security project, and even some technical complexity like plumbing and electricity. But most of all, the biggest complexity is that the physical world, and I mean by physical world, the world of sensors, are not talking the same language to the digital world. So in a nutshell, the measures are not talking with platforms which are processing the information. There are several kind of languages, and that's a huge complexity to integrate on the market. So that's the reason why we develop a software which is a cloud wizard, which translate automatically and transparently multi-protocol as an input and multi-protocol as an output. For instance, you can install a temperature sensor on one hand and connect this information to an HVAC system or to a building management system. Physical characteristics of IoT are very important. I'm talking about the building characteristics, the walls, the Faraday cages, problems that we can meet, and at the same time, you need to deal with other constraints like the range of the information to be sent, the frequency of information, so the data amount. And basically, you need to deal with two parameters, which are very important. At one hand, you have the range, and at the second hand, you have the data. So, and that's a huge parameter to be taken into consideration when it comes down to choose a transport layer for your information. So IoT projects are not one-shots. You need to think about the further integration of IoT projects with the other platform at your enterprise. And please, that's a return on experience already, do not use some toys as a hardware. You will find hardware like Raspberry Pi, Arduino on the market. It's good to play, but it's not good to implement an industrial grade projects. And most of all, you will understand that because of this complexity, you need to find the right partner to deal with. That's very important to have a good partner to work hand in hand and to organize the knowledge transfer. So we are active for most of 10 years, so some return on experience, some best practices. It's a business project, so please involve the leadership team in your project because it needs and requires to have CXO visibility. You need to find and to go for robust hardware and software. You need to have a very careful audit as well of the physical characteristic of the building in order to find the right hardware, the right software, and the right transportation layer. IoT is not one shot, so please, as a company, as an enterprise, think about an IoT roadmap. Think about the future integration of your project. Find the right transport layer in order to cope with all the challenges you will meet in the future. Find the right specialized partner. That's very key. Do not take always the big players on the market. Big players are sometimes very good, sometimes they do not have all the skills required to deal with the complexity. And one of the most important return on investment is because IoT is a living project. Please organize the knowledge transfer from your partner to your teams. This is very key for the future. So to give you some example, for 5GA together with Giga Concept, is owning all the IoT contracts for the SNCF in France. And we made for them two big projects, but we did the same for Renault and Total Energy. The first is remote meters monitoring. You know, energy consumption is very critical, even more critical today than it was before, but even some years ago, it was already very important. What we did there is first we made an audit, and you see in the picture the center of technical center of SNCF in Rennes, this one. So we have developed a unique solution on mobile phone to find what is the best coverage, the best place to put sensors and the gateway in order to have the best available network in order to get all the information available. So we have an audit box, which is made by us as well, and a software on the phone that allows you to find the best connection. And in this case, we are most of the time working with LoRa sensor, because for us, a low power wide area network application, which is the best network for us, is LoRa. When you have done this, you have several zones at the SNCF. That's a high voltage zone, which is divided in sub meters. So we define the right range. We connect to gas, water, and electricity meter to a gateway. In this case, we most of the time use the cloud gate, which is a very versatile gateway from option, and we develop our software on top of this cloud gate, and the data which is gathered is transferred to a platform made by the SNCF with special security requirements. So we use MQTT-S, and we develop specifically MQTT-S, which is a format which allows you most of the time to connect with all the available platforms. And then here you have an example of what we are doing for high voltage. You will see that we have impulsions meters, and we have as well Modbus information coming from the electricity meter. We converge everything on the cloud gate, which is the gateway, and the gateway export in MQTT format up to the SNCF platform. The second case we did for the SNCF is the lift pump management. You know, when it rains or in case of flood, you have a lot of water in tunnels, and this is very dangerous, because when the water is in the tunnel, what do the people? They are crossing the railways, and they are exposed to physical security issues. So SNCF asked us to develop a specific project for them, which is the lift pump project. So what basically, we have two kind of sensors in the tunnels. One is the level of water, and the second one gives a status of the pump. And you have a first primary pump and a secondary pump. And we develop as well an IP box for the cloud gate, and we put everything in the tunnel, so we can monitor in all the tunnels where it is installed, or the level of water and the status of the pump. And those applications are very easy to deploy, but you need to be very robust. You need to use the right protocol for communication. You need to have the right software, because this kind of project, if you don't master the end-to-end process, it can take you weeks to install. Here, for one tunnel, it takes half a day, and it's fully equipped. And this is the beauty of it, because you need to manage this complexity. And with this infrastructure in place, the SNCF is already thinking about other applications than the lift pump project to monitor train frequency, to monitor the attendance on the keys and so on. So to go back to the conclusion, IoT projects look complex because of the various skills and techniques which is involved in there. So please deploy and think about an IoT roadmap and work on priority one business case. When sometime all the requirements are converging together, and of course when you can increase productivity and profits. Follow the best practice. It's not rocket science. It's down to earth. It's just thinking about all the elements which make the complexity and to solve it. And yes, please, you can go to turnkey application as well. It's not only always tailor-made. It's sometimes like energy management, consumption management of electricity, gas, and so on, which are available on the market. And which can be the foundation for further IoT project implementation. So having said that, thank you very much for attending, and I give you the word to Nicolas.
Thank you, Luc. Thank you very much. Perhaps, Luc, please stay with us. We certainly have some questions for you. Looking at the dedicated tab, no, there is not. People are a little bit shy, it seems. Perhaps that the dual weather that doesn't help them to. Okay.
We can take the question offline as well. I'm available to answer those questions.
Sure.
Most of the time, the questions are related to what kind of transport layer I need to put in place.
Yeah, that's and that's a perfect transition with my own transition actually, because yeah, when we talk about IoT, that's the point that arrived at first about the transport layer and the standardization also that could. What's the state of the art at the moment concerning that? If you could elaborate a little bit on that.
Yes, because probably you are aware about RFID projects, for instance. This is a very small amount of data, very local. It's 1 meter range, and you can go up to 5G, which is of course a high data throughput with a very long range. But in order to avoid complexity of deploying IoT projects, most of the time we need to have battery-based sensors, which are not wired, because wiring is cumbersome. If you have sensors which are wireless, it's better. And now the battery for wireless sensors are going up to 9 to 10 years lifetime. Which is very convenient. And for this kind of sensors, LoRa is the most popular protocol. There was a kind of a battle on the market between Sigfox and LoRa, and definitely LoRa is winning the game. And you see more and more LoRa implementation, knowing that you have thousands of different sensors available for LoRa networks, which is very convenient. You can measure anything you want, and we can translate LoRa information up to any kind of platforms, being building management system, HVAC, even process platform like ServiceNow, all cloud-based application as well. So LoRa is definitely in most of the case the best choice.
Okay, and from your point of view, we could hear from here to there that 5G will replace all the protocols, and that it will be the let's say the magic transport layer. So according to what you just said, LoRa seems to have some bright days ahead.
Yeah, but you know 5G is good, but it's not the panacea. 5G can perfectly fit to for if you have to transport video on the network. Of course, you need to have one gig bandwidth. But if you need to just to transport information like consumption, like air quality, like hygrometry, or the level of the lift pump I just mentioned, LoRa is perfect. LoRa is free. In the gateway, you have a free LoRa network server, meaning that you plug your gateway and then you deploy automatically a free LoRa. There is no subscription fee. And it's the best protocol, encrypted from security perspective, easy to deploy, and of course no subscription, as I said. So it's very, very powerful for IoT.
Nice. Okay, thank you. Just looking at the chat and at the question tab, definitely no question, but I think that everybody at the time to take your contacts with this last slide, and for sure there will be some.
Yeah, please get in touch. I'm quite happy to share best practice with you.
Perfect. Thanks a lot, Luc.
Bye-bye.
Bye. So now, in order to do a smooth transition with our second expert, we would like to propose a second poll, actually. In your opinion, what is or are the main barriers to the adoption of IoT technologies today? So it could be cybersecurity, the lack of standardization, perhaps the strategic vision also of companies, and the contribution of data. Or perhaps that could be, problem could be that there is too few or poorly identified experts in the field. So let us know. One interesting thing also concerning the poll, you could see the result once you've voted. So I encourage you to do so. Next, let me introduce you Raphael Matter, who is a software engineer in the Logistic and Information System Department at Curl Solutions. So Raphael will tell us more about IoT when it comes to be embedded in devices. So Raphael, the floor is yours.
Okay, thank you very much, Nicolas, and welcome everyone. Yeah, my name is Raphael Matter, and I'm working as project manager in software engineering for Köhl Maschinenbau AG. And today I will introduce to you the Köhl IoT server by means of a concrete project, which is the TMC server project we have been developing in the recent past. Short information on our company. Köhl Maschinenbau is an engineering company based in Becker, Luxembourg, since about 20 years now. And the main fields of activities are intralogistics, robotics, automation, and manufacturing IT. And in software engineering, our focus is on warehouse management and material flow systems, as well as reporting and manufacturing execution systems. And let's have a look at the project details of the project I'm going to present. The customer is an international tobacco company, and the scope of the project was to collect real-time machine data from the production lines of a tobacco factory. And this data needs to be provided to an existing improvement program of the customer with the goal to improve the machine efficiency and thereby increase the productivity of the factory. Regarding the collected data, the main focus is on production volume, on the overall equipment effectiveness, so the percentage of truly productive manufacturing time, reasons for production stops, reasons for rejects, and monitoring changes to the setup of the machines. So let's turn to the project requirements in detail. Challenge in data collection was that in such a production line in tobacco, you have historically grown structures with many different types of machines from multiple vendors, all having different kind of PLCs, like you have controllers from Siemens or Beckhoff, or you have sometimes plain file interfaces. So the requirement was not to change the existing PLC programs, as this is linked to a lot of efforts for us and the customer and could have potential side effects on the production. So this had to be avoided. And further requirements were that you need a normalization of data. The data has to follow a specific standard, with the goal to access the data from all machines in the same way, regardless of the vendor and machine type. So that makes it possible to compare the machines and compare the production lines and have a simpler, smart analysis later on. And for this task, the data should be published by our server as an OPC UA server, following the TMC standard, which I will come to shortly after. And further requirements of the customer were to have a decentralized solution, so that every machine should provide its normalized data instead of a central server dealing with it. Here you can see the data flow in the system. So in the blue box is the scope realized in this project. So we have implemented small industrial PCs directly in the production line, installed in cabinets, and collecting data from all the machines and different PLCs. And we are publishing this as OPC server. And on customer side, there is an OPC client, which subscribes to the published data, stores it in a central data lake in the cloud. And from there, it can be used for analysis by a business intelligence software, and then being accessible for all locations of the company. And in regards of this OPC communication, I can give a short explanation of OPC for those who might don't know it. It's open platform communications. It's an industry interoperability standard since 1996, and the new redesigned version UA since 2006. It's a comprehensive standard for data exchange for any kind of devices or systems in the industrial environment, from sensors and PLCs to higher level systems like an MES or a warehouse management system. You can read and write data between the systems, including method calls. You can access data in real time. You can access historical data, monitor alarms and events. And it covers the client-server architecture, including all security management. It's cross-platform, not bound to any operating system or programming language, and it's open source, managed by the OPC Foundation. An important feature for this project was the companion specifications. So OPC includes an information model hosting the basic objects, classes, types, which are used for data exchange between the systems. And built on top of this are companion information models defining objects for specific industrial areas. So there are now more than 60 standardized data models, for example, for chemical plants, for mining, plastics, robotics, and also for tobacco in this case. And on top of these, you could also build your own vendor-specific extensions, as it's open source. So if you have your own product, machine, or software, you can specify the data models with the methods and state machines and flows which are needed for your case. So then we're coming to this TMC standard. It stands for Tobacco Machinery Companion Specification. And it was developed by a working group of all major tobacco companies. And its information model includes machine configurations, product flows, setup of machines, life status, historical information. So with this TMC standard, it's theoretically possible for any stakeholder, like in operations, service, software supplier, hardware vendor, to read such a model and from any factory or company, and then understand how production is set up, how the production flow is, how machines are configured, how they are actually performing at the moment, and you have also the possibility to control the systems via TMC. So you could also send production orders from a higher system to the machines. There are freely available OPC standard tools like the OPC UA browser. So in the screenshot, you can see an OPC browser connected to our server for, in this case, a case packer machine. So a machine which is packing the finished products into cartons. And you can browse through the complete data model. On the left-hand side, you have an excerpt from such a data model tree. And you get there the basic information like machine vendor, model, version. You get the live status of the machine, if it's running or idle. You have the objects for connected machines, for machine input and output. So I've opened here the material outputs. And on the right-hand side, you see you can subscribe then to live values from the PLC. For example, here you can get the total output of the machine and also watch the trend of the values. Also possible to subscribe to events. So our server will publish an event for all data changes or warnings which occurred in the underlying systems. And we publish an event with message, severity, additional information as needed. So this can be alarms forwarded directly from the PLC. Can be events about machine start and stops, about downtimes, and also periodic information, for example, about production volume, that you get an event every minute or every once per shift to see how the production increases and how many defects there are, for example. And you have an historical browser, so you can search for events in the past. So then let's move on to the details of our solution, our IoT server. Our system is built with Java on the back end and JavaScript, Angular on the front end. We are platform independent, running on Windows or Linux, and it has minimal hardware requirements, as we can also run on small industrial PCs with very limited memory. And it's possible to have a centralized or decentralized solution. So you can go for one server per machine, like in this project, or you could go for a central solution with one more powerful server collecting the data from complete production line or complete factory. The server follows a data-centered design. So out of the software is the central data storage, and input-output connectors can read from and write to the storage. So when a connector writes to the storage, this change can trigger then the output of another connector. For example, as input, PLC connector periodically pulls from the PLC and writing to the storage, and the changes are then published to the TMC server as output. And vice versa, the TMC server can also call a method, which is then forwarded and executed on the PLC. Another example could be OPC as input, so reading from another OPC device, and then a database or web service as output connector. And of course, the data change can also trigger multiple connectors at the same time. And specialty is then a connector for this specific OPC Companion Specifications. The server features data persistence for historic access, and also in short term for the purpose of fail-safe data access of the client. So when an OPC client, due to network, was disconnected, then after reconnection, it can automatically retrieve all the missed data of this period. Important features are transformation and normalization. So most of the time, the shop floor systems do not provide the data which is needed in analysis, or not the data which is required from the TMC standard, for example. So you can normalize the data on the fly directly to use the needed display formats or the engineering units which are required. We also do calculations, for example, simple mathematical calculations like you get the output of a machine and you get the number of defects, and you want to calculate the production ratio of good products. Or more complex calculations could be downtime calculation. You monitor the life status of the machine when it was stopped and then back started again. And we monitor the alarm messages from the PLC prior to the downtime. So then we combine this information to create a downtime event with already the list of stop reasons and the duration of the downtime. And as all machines are different, all projects are different, the connectors are configurable via a web interface or by config files. So there's no change needed in the program code of the IoT server. And also the calculations can be managed by files. So by integration of a lightweight scripting language, you can define and change calculations even during runtime. There's also central monitoring. As such a production line then can comprise of hundreds of machines and servers. You have a central monitoring allowing to control the system health of all servers and manage all instances centrally. Yeah, this server comes also with a simple web interface. So you can monitor the used connectors, start and stop them. You can change the configuration or the addresses for the source and destination systems. And you can also check the data which was received from the other systems and check the log files. That ends my talk for today. So you have seen the usage of the IoT server in the tobacco environment, but our server is of course not limited to this. So it is under constant development, and now we are developing further communication protocols like connectors for Modbus and MQTT in the shop floor, and further cloud and database connectors. Yeah, then thank you very much for your attention, and I'm ready for questions.
Thank you, Raphael. Thanks a lot. Very interesting to see how you integrated all the aspects into this project. And by the way, could you tell us more about how simple it is? What's the effort you have to do in terms of training, for example, when it comes to set up your IoT server?
Yeah, the server itself, I would say, is plug and play. So you have to set it up in the network, but then it's up and running directly. So the job which has to be done then is configuration, but that's the one-time job. Setting up all the addresses of the source destination systems. Eventually, you need to define transformations, but this can all be handled with configuration and import of Excel files, for example. And then after the system is set up, it's running in the background, so there's no need for operators for training. It's a maintenance-free system. I think probably most efforts are if you have legacy systems with kind of old PLCs, that sometimes it's difficult to find out where to collect the data from. If the PLCs are maybe poorly documented, customer or then we need to analyze the programs to find out where to get the data from.
Okay, thank you. Perhaps in the audience, let me check. No, there is no question. Perhaps some are arriving. Let me check about the time. So that could be a good occasion to do a little focus on the two polls we did and have some encouraging news for you, Raphael. The answers are pretty positive and enthusiastic regarding the topic. If we look at the first poll, so it was about knowing if people do collect some data at the moment, and a large part of our audience, 64%, answered yes, and I make extensive use of it. So that's encouraging, actually. That demonstrates that there is something in the air. And for the second poll, people have answered so about the barriers to the adoption of IoT. People have answered that equally that it could be a strategic vision of the company and the contribution of data that's not sufficiently developed, and also the lack of standardization, especially in the communication protocol and therefore connectivity. That's the two main barriers identified by our audience. You want to add something, perhaps, Raphael, on this, based on this poll and these results?
Thanks.
Okay, perfect. Thanks a lot once again. Now it's time for us. It's time for this new and appreciated new session of this webinar. Today, let me introduce you Cedric Dockendorf, who is the co-founder of Symvio, and a Luxembourg startup precisely in the IoT field. And he will pitch us about his solution. Cedric, what is yours?
Hello, thanks for having me today. I'm super happy to be here and show you what we are doing. Let me pull up my slides. Voila, by now you should be seeing my slides. So my name is Cedric. I'm one of the founders of Symvio, and I'm very pleased to show you what we do. At Symvio, we work with mid-sized manufacturing business, and in particular, we work with their production and maintenance people, and we help them understand their machines better so that they can improve the productivity of their production lines. Let me give you a simple, I want to use the short time I have here to give you a quick example of a type of project that we do. So this is the example of a manufacturing business. It's a food processing business in Germany. And here in the picture, you see Andre. He is the technical responsible for the factory. And like many of his peers, he's constantly firefighting. He has to keep machines running. His job is to make sure that products can be delivered, but he doesn't have any real information on the health of the machines that he's in charge of. So he has to accept, he only has two choices. He accepts unplanned downtime for some of the machines, or he does preventive maintenance according to OEM recommendations, but he doesn't really know where or when he should do more targeted maintenance. And that's why he's in the constant pressure with time and budget, and he doesn't get out of this firefighting mode. And the problem is that he knows also that digital solutions using data and sensors could help him, but he doesn't really have time to understand this in detail. But he wants to have something that he could try and test. And that's where we learned in this project, we learned that there is a need for simple, intuitive solutions to get an easy start into digital projects that go a bit beyond just using PLC data, and that don't require the big efforts to start. And that's where we work on today, to develop simple solutions for intuitive IoT in factories. Especially in Andre's case, it was very difficult because he had a heterogeneous machine park. They're not all from one manufacturer. Some of them are old, some of them are new. So we need something simple to work with him. And when we want to help him is also to spend his time better. Like when we looked at Andre, we learned that he spends his time on a lot of non-value adding tasks. But we want him to be able to spend his tasks so that he doesn't have this firefighting mode. He's tasked there where he can bring the most value. That's problem solving, or maybe also planning, but not necessarily on gathering information, doing analysis, or just waiting for something to happen. And this is where we want to help him. So what we came up for him is just a simple solution where we use a wireless vibration and temperature sensor to collect data from his various machines. We bring that data to the cloud and show it to him in a web-based interface. Let me quickly, if I turn around or I stop the sharing here, I'm not sure if you can see, but let me show you in the small window here. I have a small setup here. So this is my sensor that measures vibration and temperature. I can just put it on this little motor, and then we collect the data into a, we have a ready box, a connectivity box, where we have a processor and a gateway, and then we can give him the data into the cloud where he needs it. So if I go back to my presentation now, so we help him with something very simple, just to get the data to the cloud and have data that he can analyze. And then we learn how the machine behaves normally, and we detect deviations and can give him an alarm whenever it's time to look at the machine, when we detect changes. So we have a very small entity to digitize small bits of a factory, and we can repeat that many, many times. So we don't have a big complex project to get data from legacy machines, but we have a small thing which takes only 15 minutes to set up and install, and we can repeat that as often as we want in a factory to start digitizing and collect data. And so Andre, in our case, he gets automated fault detection on some of the devices that he monitors. We can also help him build other metrics such as runtime or downtime, so that he has a better understanding of his operational performance, and he has a real-time overview of the assets that he monitors in one simple dashboard. And we do all of this by monitoring vibration over time. And this is how we think we can give a contribution to make manufacturing here in our region more sustainable and resilient. That's all I wanted to show you today. I'm happy to answer any questions or talk to you at any later point. My contact details are on the slide, so feel free to reach out and we'll talk to you.
Thanks a lot, Cedric. Very interesting, and I guess that could bring some ideas, some fresh idea to people that attend, and to make them realize that IoT could be simple to integrate as and the solution you propose by its plug-and-play aspect demonstrate that clearly. So perhaps let me check if there, because we still have some time a little bit. No question. Yeah, so let's continue. Just a minute, please. Yes. So, guys, all of you, Luc, Laurent, fortunately couldn't attend. Raphael and Cedric, thanks a lot for your presentation, and we deeply hope here in the Digital Innovation Hub that your presentation will permit to initiate some ideas or some discussion, and even, why not, some partnerships, because at the end, that's our mission, and once we are here for that. So, I promise that the very last poll of today, our feedback is very important for us. That's based on that we will do better next time. So if you could please tell us about your experience during this edition of during this episode of the webinar, that could be very nice. Some few information. Perhaps you already heard about the DIH tour that just finished. We were for 3 weeks in 9 stages all around the country. But at the end, it's not it's not finished yet. There's a surprise because the bus will be parked in front of the Cybersecurity Week at Lux Expo on the 20th and on the 19th and 20th, sorry, October. And what is important to precise is that on the 19th, there will be 7 sessions on cybersecurity / industry topics. So you could register through the link that is being shared by my colleague. Thank you, Ocean, and through direct.lu/events. So that's a wrap. It's time to close this webinar now and meet to the not last, actually, that will not be the last episode of this year on the 19th of November. This episode will be dedicated to AR and VR and how they could contribute to the digitization of the industry, how they could play a role in the Industry 4.0 field. So you could register from now, and by the way, you could also already register to the webinar of December. That will be the last episode, and we will for sure come back next year with some great topics. So thanks a lot. Thanks again to our speakers. Thanks to my colleague Ocean. Thanks to you, the participants, the public. And see you in November. Bye.